All right, on Wednesdays, we are pink. You guys will be able to use scientific notation in writing, multiplying, and dividing, section 6.3, okay? Scientific notation. So, how many of you guys, show of hands, have done scientific notation before? All right, I'm seeing lots of hands. Where have you guys done it before? Science with Mr. Olson?
No, not science.
No, math with Mr. Olson. Okay, last year, yep. Last year, one of the 3 or 4 teachers he had for math. All right. Okay, sorry. Okay, so scientific notation, what do you guys know about it? Okay, it's kind of the short version of a number. It's a way to write a big or small number, but more abbreviated. Okay, what else do you guys know about it? Okay, it's scientific. Okay, it's normally used in science when you have big or small calculations. Okay, anything else you guys know about it?
No.
Okay, well, hopefully this will serve as a good refresher then, and maybe even an expansion. I guess we'll see.
It's
So,
written with a thingy, like a exponent.
an exponent. Okay, so it might be fitting that we're doing it this chapter with our exponents. Okay, so in scientific notation, numbers are always written in the form of a times 10 to the power of b. So you have a number times 10 to a certain power, where b is an integer and a is between 1 and 10. So that means there's exactly one non-zero digit before the decimal. This notation is especially useful for numbers that are either very small or very large, big, ginormous. Okay, let's explore why scientific notation works, how it works, okay? So when you have 1.07 times 10 to the fourth, we're going to say that's going to be equal to 10,700. So how does that work? Okay, well, 10 to the fourth, we talked about the other day a shortcut for doing powers of 10, right? You guys remember that? What was kind of the shortcut for doing powers of 10? Add 4 zeros. So it's going to be a 1 with 1, 2, 3, 4 zeros behind it, okay? So that's 10,000. So now we're taking 1.07 times this 10,000, okay? Zeros behind it. So now, what can we do when we multiply by a power of 10 like that? Do you guys know?
Subtract.
You guys know the shortcut here? You just end up really moving this decimal by however many zeros there are. Okay? What happens mathematically is you take 1.07 times 10,000 like this. 0 times 0, well, the whole first number is just going to be 0, right? The whole first 4 numbers are just going to be 0 because you're just going to 0 times everything, 0 times everything, 0 times everything, 0 times everything, right? Does that make sense or no? Okay. Then we're going to have the 1 times everything. So 1 times 7 is 7. 1 times 0 is 0. 1 times 1 is 1. But we had started out with 2 numbers behind the decimal spot. So how many numbers have to end behind the decimal? 2. So that's how we end up getting 10,700. 10700. 10700. So what we essentially did was we took 1.07 and move the decimal spot 1, 2, 3, 4 times. But we notice we have blank numbers here. What do we put in those blank numbers?
Zeros.
The zeros. And that's how we end up getting 10,700 with the decimal now to the right of that final 0. We see the same thing happen on 1.0 times 10 to the third. If we look here and we move the decimal 1, 2, 3 times, we have to add in a 0. We get 10,070. Same thing here, 10 to the second. Move the decimal 1, 2 times, 107. Move the decimal 1 time, 10.7. Move the decimal 0 times, it's the same thing. Hey, wait, what's anything to the power of 0, guys?
0.
Not quite? 1. So you're really just doing 1.07 times 10 to the 10 times, 1, making it the same. Negative exponents. Well, if a positive exponent is going to make us move the decimal to make it bigger, what do we think a negative exponent is going to do? Make it smaller, okay? 10 to the negative first is actually 1 over 10, right? Because the negative exponent sends it downstairs. So you're dividing by 10 rather than multiplying by 10. So that's like by multiplying by 1 over 10 is the same thing as 0.1 or 0.1. Because it's a tenth of something. Either way, it's 1/10 or 1/10. So when you do that, we take this 1.07 and we move the decimal 1 to the other direction. And look what happened. It went to the left there, so now it's 0.107. Move it 2 decimals. Have to add in a placeholder when you move it 2 decimals, though. And so you get 0.0107. I was on the wrong one. 3, move it 1, 2, 3 decimals. 4, move it 1, 2, 3, 4 decimals. Do we have any questions on this so far? Okay, I want you guys to write this part in that I'm about to write in the pink, okay, because it's Wednesday. Feel free to abbreviate this however is going to make sense to you, okay? Positive exponents make the number bigger. Okay, abbreviate that however it's going to make sense for you. So if that makes sense to you how I abbreviate it there, do that. If it makes more sense to you to write out positive exponents, write out positive exponents. If it makes more sense to you to use a plus sign rather than positive, use a plus sign rather than positives, okay? You guys are taking your own notes for your benefit, for you to be able to look at and use, for you to remember. So do what's going to make sense for you, okay? Does that make sense?
Yeah.
Okay? All right. The negative exponents, what are those negative exponents going to be?
Make them smaller.
They're going to make the number smaller. Very good. And then this power of 0, well, 10 to the power of 0 we said is just 1. So it's going to keep it the same because anything times 1 is itself. Okay? I also want to think of it this way. Let me grab my meter stick here. So this stick is 1 meter long, 100 centimeters. Okay. You might be wondering why it's kind of taped up. It's because Mrs. Moorhead. Do you guys know Mrs. Moorhead?
Yes.
Okay. She one time a few years ago broke this in class. So she was. Yeah, actually.
Who was she hitting?
So she didn't hit anyone. She actually just broke it over her knee one time. So I can't remember exactly the context of why it happened, but it was pretty funny. Also, fun fact about Mrs. Moorhead, okay? She's a black belt.
Wow.
Like straight up. She's a black belt. I'm not sure what martial arts it was in. Yep, straight up, she's a black belt. Anyway, so I have this meter stick. Okay? So let's say here, 1.07 times 10 to the 4th. Well, as we go to the normal number, did our exponent of 4 get bigger or smaller? Okay, so let me rephrase that. So as we go from 10 to the 4th here, we end up having 10,700, and that's really like a 10,700 times 10 to the power of 0, because it's really like times 1, so it doesn't change anything. So our actual number got a lot bigger, didn't it? 1.07 got a lot bigger. But our exponent did what? Did it get bigger or smaller? From going from 4 to 0. It got smaller, okay? So I like to think of it this way, okay? So I have my meter stick here. When my number, or excuse me, when my exponent got smaller, okay, think of this side as exponents, this side as actual numbers. As my exponent got smaller, there's less exponent. What happened to the number? It got bigger. There's more there. It's not like as one gets smaller, the rest of it just goes away. As one got smaller, it had to go somewhere. Okay, thank you. So, da. Ooh, that's an L. All right. So down here, when the negative exponent is going up to 0 again, the negative exponent, did it get bigger or smaller? Okay, that was very nice of you. Okay, did the regular exponent get bigger or smaller there? See me, the exponent of negative 1. Does it get bigger or smaller to go to 0? Bigger. So the exponent, once again on this side, gets bigger. So what happens to the regular number? It gets smaller to compensate. And we see 1.07 become a smaller decimal. Okay? Is that making any sense to anybody?
Yeah.
Alrighty.
This class.
Yo, you're like a month late. Alright. Alrighty. So, write the following numbers in scientific notation, okay? Well, if we look at number 1 here, 52. Where's the decimal at in 52? It's at the end, right? It's after the 2. My goodness, I'm dropping everything today. Hot mess. All right. So, I'll thank you. Appreciate the understanding. So, it's after the 2 right now. Where do we want the decimal to be if we're going to have this number in scientific notation? Okay, not before the 5. How many numbers do we want in front of the decimal? And we want exactly 1 number, so we want it between the 5 and the 2. So how many spots do we need to move this decimal? 1 spot. So we're going to make this 5.2 times 10 to the... Well, how many spots do we move it? 1. So we have to figure out, do we make this a positive or a negative one? Well, I'm going to go back to my meter stick trick. Okay? So, did my actual number become bigger or smaller? It got smaller. So my number got smaller. What happens to my exponent? It gets bigger. Positive 1. Okay? The number that's there is determined by how many spots you moved it. Positive or negative? Well, did the actual number get bigger or smaller? Okay? Because it's going to be the opposite of that. Does that make sense? Because as this gets smaller, the rest of it had to go somewhere. So it goes to the exponent to make it bigger. On the next one, 8,542. This is a comma. Be very careful. Where's the decimal at here? After the 2. Very good, Elijah. So how many spots do we need to move the decimal on this one? 1, 2, 3. We want 1 number in front of the decimal. So we want it after the first number. So we want this to be 8.452 instead of 8,452. Now how many spots did we move the decimal? 3. Now when we ask the question, do we make this positive or negative, I'm going to ask myself again, did I make my actual number bigger or smaller? The actual number got smaller, so what happened to my exponents? It got bigger, positive 3. Yeah, Allie? Okay. Let's look at number 3. I want you guys to try that on your own, okay?
This looks gross.
Oh, okay. As we look at this one, the decimal's at the very end right now after the 0. We want it to be behind the 2. I saw most of us kind of caught on to that, which is great. So we move it 1, 2, 3, 4, 5, 6. I was going to mess up there. 1, 2, 3, 4, 5, 6, 7, 8 spots. So we want it to be 2.4831245. I actually don't need to put the 0. I'll tell you why in a moment. Times 10 to the 8th.
Is it wrong to do?
In science class, they might count it wrong. In math, I'm okay with it, but in science, they might count that wrong. So here's the reason why I don't need to put the 8. If I were given this number right now in the answer and was told to put that into regular form, I would take this and I'd move the decimal, right? Okay, blessing must rain down after the script. Let's just do that down here for a moment. So 2.48311245. And I move the decimal 8 spots. 1, 2, 3, 4, 5, 6, 7, 8. What do I assume is going to be in that blank spot? A 0. So I'm assuming it's going to be there, so I don't need to put it on at the end. But I need those other numbers, because if those other numbers aren't there, what am I going to assume was in their spots? 0. And then is that the same answer? No, not even close. Okay, so we have to be very careful with that, to where we can only leave off what we call the trailing zeros. Okay, oftentimes they're called trailing zeros because they kind of trail at the end. Okay, you guys know what it means for things to be trailing? Okay, it means they're kind of like following behind, right? At the end. Yeah, Raquel. Okay. Okay. So the trailing 0 we don't actually need there. Okay, because we'd assume there's a 0 there. Any questions on number 3? All right, on number 4. 0.04. How many spots do we want to move the decimal? Courtney?
0.
Okay, we want to move the decimal 0 spots?
I think we should leave it.
Okay, you think you should leave it. What does everyone else think? Elijah, what are you thinking?
2 to the right.
You thinking you need to move 2 to the right?
No, 1 to the right.
1 to the right?
Yeah.
Okay, Elijah's actually changing that. He thinks 1 to the right, okay? Alice, what do you think? Okay, Alice, why are you saying 2 to the right? That's exactly right. Alice is correct. Here we have to have 1 number in front of the decimal. So here we want the 4 in front of the decimal. So we're going to move it 2 spots. So this becomes just 4, or you can call it 4.0 if you really want, times 10 to the, well, how many spots do we move it? 2. But now, yeah, the question becomes positive or negative. Go back to my little meter stick. Did my actual number become bigger or smaller? It got bigger. So what happened to my exponents? It gets smaller. So what kind of 2 is this? It's a negative 2 as it gets smaller. Okay? Is that a trick you guys could do on your homework and your test, just even with your pencil? Holding up your pencil, okay? My number got bigger, my exponent got smaller. Okay, negative. Okay? Oh, my number got smaller, my exponent got bigger. Okay, it's positive. Okay? You guys could do that on your test, right? Okay? So if I look around during your test and see you guys with like holding up your pencil and doing this, I'm not gonna think it's weird, okay? Someone walking by the hallway might, but that's okay.
What if you wrote the answers on
Ooh. Then we might need to have some disciplinary action. All right. Ooh. Okay, let's look at number 5 here. Where do we want the decimal to be? Between the eighths. Very good. We want it to end up here. So we have to move it 1, 2, 3, 4, 5, 6, 7 spots. So we're going to call this 8.8 times 10 to the negative 7th. The actual number became bigger. So as the actual number becomes bigger, the exponent gets smaller. Very good, very good. Okay, nailed it. So it becomes 8.8 times 10 to the negative 7th. And we don't need those zeros there, because if we were to move it back, what would we assume is going to be in all those blank spots? All these zeros. So does, in my opinion, I think this looks a lot cleaner than this does. And as you get into different things in science, okay, especially maybe like, biology or chemistry especially, okay, or physics, if you were to take those classes, you'd end up seeing a lot of numbers that are very big and small that you have to use in different calculations, okay? And so as we use these, it'll be very helpful to have it written in this way, so that way you can easily tell and compare numbers without having it take up your entire paper, okay? Let's look at this final one here, okay? Where do we want the decimal at this time?
behind the 2.
Okay, I heard a couple different answers. I heard someone say at the end. I heard someone say behind the 2. Okay, the answer is going to be behind the 2. Because how many numbers do we want in front of the decimal? Excuse me. We want one number in front of the decimal. So we want this to be 2 point. Do we need these 3 zeros?
Yes, because I'm not trailing.
Because they're not trailing. We call this sandwich zeros because they're sandwiched between the 2 and the 8. Okay, just like when you make a sandwich, okay, things are between the 2 pieces of bread. Okay, or if you're making like it with like lettuce, then they're between the lettuce, I guess. But I'm not going to make it with lettuce because I like bread and I don't like lettuce. Anyway, so 2.008 times 10 to the, how many spots did we move the decimal? 4. Now is this positive or negative? Negative, because the actual number became much bigger. If you don't have those zeros there, okay, what's going to happen is you'll call this 2.8 times 10 to the negative 4th. And that's not the same thing. Because as you move this decimal 1, 2, 3, 4 times, you're going to think it's 0.00028. And it wasn't that at all, was it? Okay, much different. Sorry, what? Okay. Just making sure. Anyone have any questions or still need that at all? All right, let's continue on and hear some pages rustle. That's awesome, okay? So now we're going to go the other way around. We're going to take scientific notation. We're going to put it into normal. 4.203 times 10 to the 4th. Okay, we want this exponent to go away. So we're going to make the exponent smaller down to 0. So what's going to happen to the actual number? It's going to get bigger. So where am I going to move this decimal? To the left or right? To the right. How many spots? 4. Okay, what I suggest? Either doing it here or writing it again and moving the decimal 1, 2, 3, 4 spots and filling in that 0, saying 42030. Do you guys know the rule for where to put commas? Does anyone know the rule for where to put commas when you do numbers by chance? Okay, you do it every 3. So you start at the end, you count 3. So 0, 3, 0, that's 3 numbers, put a comma. You could, if you wanted to do 42,030 and then put decimal 0, you could. You definitely don't have to, though, because there's an implied decimal, just kind of like you assume, or it's implied that there's a 1 in front of any x, or there's a 1 for any exponent that's not shown. You assume, or it's implied, that the decimal is at the end. All right. I want you guys to go ahead and try number 2 on your own. Raise your hand or if you have it or have questions. Ooh, okay. Literally like almost everyone. Okay. All right. I'll give another few seconds for that one then. You can guys go ahead and put your hands down. All right. Who wants to share what they have on this one? Okay, Abby Dasher, go ahead. Oh, sorry. I got my Abby's mixed up there. I was actually trying to call on Abby Simmons, but I already called on you, Abby. So if you want to do it. Nailed it. 320,000. We want to move the decimal 5 times. Now here, you might notice it kind of gets a little awkward to put all those little whooshes, so to speak, those swoops there. So it might be helpful to say 3.2, maybe like write it somewhere else, even write it below it if you want. And say 3.2. Now move the decimal 1, 2, 3, 4, 5. Okay, those are all getting filled in with blanks. 320,000 is my answer, okay? Questions on that? All right, on number 3, how many spots are we moving the decimal?
0.
Literally none. So what's our answer? 3.14. What's that the start of? Does anyone know? Pi. It's the start of pi. The first 3 digits of pi.
There's a lot. What? Okay, I memorized 30.
You what?
Yeah.
Yep, so the 10 becomes the 1 because the 0 is on the 10. Very good question. So it's like you multiply it by 1, so it stays the same. Love that you're asking that. 1.88 times 10 to the negative second. Is our actual number going to become bigger or smaller? Our actual number is going to become bigger because the exponent becomes smaller, right? So, excuse me, the exponent becomes bigger, so the actual number becomes smaller. So the actual number is going to become smaller as the exponent becomes bigger to go up to 0. So where are we going to move the decimal to? 2 to the left. 1, 2. Place a 0 there. 0.0188. Question gets asked. Mr. Costa, do I need a 0 before this decimal? Technically, no. Is it wrong to put it? No. It's your preference. If you want to put a 0 there, put a 0 there. If you don't want to put a 0 there, don't put a 0 there. Just make sure your decimal is pretty obvious, though, okay? Maybe don't make it this obnoxious and do like this. But make sure it's obvious.
How do you decide where to put the decimal?
So on this one, since you have to move it 2 to the left, it started out here, so we move it 1. Now it's to the left of the 1. You move it 1 more spot, you have to put that 0 for your placeholder, so it goes right here. Does that make any sense or no?
Well, shouldn't there be another 0 before the decimal?
Before the decimal? You can if you want, but you don't have to.
Oh, okay.
So if it was times 10 to the negative third, you'd move it 1 more spot even then. But it was here originally, so we moved it 2 spots now.
Okay.
Does that make sense or no?
Yeah.
All right. On number 5, I want you guys to try that.
Do you want us to raise it?
Alrighty, okay. No need to raise your hand. Okay, I'm looking around and it looks like you guys are nailing this already. Okay. Josh, what do you have for this one? How many spots did you move the decimal? 4. Okay, you moved to which direction? To the left. As the exponent gets bigger, the number becomes smaller. So how many zeros did you have before the 5? 4. So you had 1, 2, 3, 4 zeros, and the 5. Now, if we want, we could put a 0 here before the decimal. Don't have to. I'm showing an example with it on number 4, an example without it on number 5. Now, guys, was number 5 in scientific notation to start with?
Yeah.
Nope.
Wait.
No.
No, it wasn't.
Why not?
Because there's no number before.
But the 0 is technically not there.
Great question. Yeah, because 0 is technically not before the decimal. So there's technically no number before the decimal. So it's actually 5 wasn't in scientific notation to start. Okay. Any questions on this, or do we feel good about this?
I think you're
Okay, give me a thumbs up if you're feeling good, thumbs down if you're not. Be honest with me.
feeling good. I should.
Okay. In your Sunday best, feeling blessed, okay? Moving on.
Oh, we're not doing 6?
No, we're going to skip 6. You guys are feeling good. Multiplying and dividing in scientific notation, okay? So, here, we have 2 times 10 to the 5th. That's scientific notation. 4 times 10 to the 4th. That's scientific notation. And what are we doing between these two parentheses? Multiplying. So we're multiplying scientific notation. On numbers 4 through 16, notice we're doing the same thing, but we're dividing between the parentheses. So we're multiplying and dividing really, really big and really, really small numbers. So what we're going to do is we're going to group the numbers together and group the powers of 10 together. So what are the actual numbers between these two parentheses? 2 and 4. So I'm going to group those together in a parenthesis. So I'm going to do, in the first parenthesis, 2 times 4. And I can do 2 times 4 with a dot as well if I want. I don't need to put the 0.0 or point on either of them, because 2.0 is the same thing as 2, right? Just like whether I say $2.00 or just $2, or 2 minutes and 0 seconds or 2 minutes, it's the same thing. Now I'm going to group the powers of 10 together. So I'm going to have 10 to the 5th times 10 to the 4th. So do I still have all of the same things written, just in a different order now? Okay, and the reason this works is because multiplication can happen in any order. Okay, we talked about that before, how we can reorder that multiplication. So I just reordered the multiplication. Now, 2 times 4 is 8. 10 to the 5th times 10 to the 4th. Those are the same base, so what do we do with the exponents? Add them, so it becomes 10 to the 9th. And what operation is happening between these two parentheses right now? Multiplication. This becomes 8 times 10 to the 9th. Is that answer already in scientific notation? Yeah, it totally is. One number before the decimal. Now, if you wanted to, here's the other way you could write this one out. You could actually say 2 times 10 to the 5th, 200,000, times 4 times 10 to the 4th, 40,000. And then go through and say, okay, 4 times 2 is 8. Add up all of these 9 zeros. But then it says, write your answer in scientific notation. So what would you have to do? Move it back into scientific notation. Do you get the same answer?
Yeah.
Sure. Okay. It's a longer way to do it, but you get the same answer, okay? Elijah, yep, go ahead. Good luck.
Do we have to go, do we have to solve that,
Yep, you'd have to write your answer in scientific notation when it asks. So you'd have to put it back into this form anyway.
No, I'm saying, do we have to put, that, not, yes, I know we have to put that, but do we have to put that, the big number, do we have to put that, no? We just write it?
Nope, you really only need the green here. I'm just showing the pink's a different way to do it, but we would still need that green answer. All right, number 2. Can anyone help me on how I would do this problem? Okay, Eli, what are you thinking?
3 times 5.
Okay, 3 times 5.
And then 10 to the 10 squared times 10 to the 6.
Very good. So group the normal numbers together, 3 and 5. Group the powers of 10 together, 10 to the squared, 10 to the 6.
Then 15.
Okay, 15, 3 times 5.
And then 10 to the 8.
And then 10 to the 8th, add those exponents. Now, is this answer in scientific notation right now? No. Tricky. How many numbers are in front of the decimal? 2. How many numbers do we want in front of the decimal? 1. So we need to move the decimal 1 spot. 1.5 times 10 to the... Okay, we move the decimal 1 spot. So the question becomes, does the exponent get 1 bigger or 1 smaller? Go back to the meter stick. Did the actual number get bigger or smaller?
It got smaller.
It got smaller, so the exponent gets bigger. So this becomes times 10 to the 9th. 1 bigger, because it moved 1 spot. Any questions on that one and how that worked? Why do we get that? How do you know that? That kind of stuff? All right, let's look at number 3. So, can someone help me kind of walk through this one the same way Eli did on that last problem? Okay, let's go ahead, Brady.
Do 2.5 times 4.
Okay.
And then, 10 power negative 3 times 10 power 4.
Very good. Normal numbers, powers of 10. 2.5 times 4, let me think about it this way. 2.5, $2.50. What would cost $2.50 at the concession stand?
Pickle. No, a hot dog.
Okay, hot dog. Let's say you're with your family at a game. Concession stand's there. Mom or dad says, hey, son or daughter, grab us 4 hot dogs. Okay, you go to the concession stand. $2.50 for 1 hot dog, you're getting 4 of them. They're going to say it's how much money? $10. 10. Okay? If that concession stand math doesn't help you, right off to the side, 2.5 times 4. Nothing wrong with that. All right. Times 10 to the, what do we do with those powers of 10? Add them, so we get 10 to the first. Now, is this scientific notation? No, it's not. Okay? Because we have two numbers in front of the decimal. So we need to move the decimal how many times? Once. 1.0 or just 1 times 10 to the what? Second. Make it 1 bigger because the actual number got 1 digit smaller. Okay? Question on that. Now we said the difference between the first 3 and the last 3 is what? Division. Okay, we have this division symbol now. Here's how it's going to change it. We're still going to have the 8 and 4. We're still going to have the 10 to the 7th and 10 to the 3rd. But now, instead of taking this multiplication symbol and putting it into each of these parentheses in between the numbers and powers of 10, we're going to take this division symbol and put that symbol between the two. So it's going to be 8 divided by 4 and 10 to the 7th divided by 10 to the 3rd. So what is 8 divided by 4? 2. 10 to the 7th divided by 10 to the 3rd. What did you want to divide with the same base? Subtract the exponents. What's 7 minus 3? 10 to the 4th. But the parentheses are still multiplying between them. So it's still 2 times 10 to the 4th. And that is in scientific notation. The long way which supports that math shows that 8 with times 10 to the 7th would be 8 with 7 zeros. Okay, 80 million, over 4 times 10 to the 3rd, so 4,000. Well, you could kind of, so to speak, divide out 3 of those zeros, and you have the 4 and the 2, or 4 and 8 become 2 and a 1. So you end up with 2 with how many zeros? You end up with 2 with how many zeros? Okay, with 4 zeros. And notice, 2 times 10 to the 4th. Ends up being the same answer, right? Can anyone help me set up number 5? Okay, Courtney, go ahead.
4.5 divided by 1.5.
Very good.
And then 10 to the 7th divided by 10 to the negative.
Very good. Group the normal numbers together, group the powers of 10 together. This time, we're dividing in the parentheses instead of multiplying. 4.5 divided by 1.5. I'm going to put this in concession stand math again. Mom or Dad wants to go to the concession stand. What's something that would cost $1.50? Candy bar. Okay? So, how many candy bars can you get if Mom or Dad gave you $4.50, 4.5? You can get 3. Is there any money left over for Mom and Dad? No. It's 3. If that doesn't work for you, do the division off to the side. If you need a refresher on that, let me know, okay? 3 times 10 to the... What do we do with those exponents? 7 and negative 2. Subtract. Now, could this get tricky here when you're doing 7 minus a negative 2? Yeah, you'd end up really adding them. So we get 10 to the what? 9th. Now, we double check. Is this in scientific notation? Yes, sir. It is. What's up? Okay? Does it make sense?
Yeah.
All right. Let's look at number 6. Someone help me set up number 6 here. Okay? Go ahead, Abby.
You do 7 divided by 3.5.
Okay?
In parentheses, yeah, obviously. And then 10 to the negative 6 divided by 10 to the negative 4.
Nailed it. Okay, I'll put this one in concession stand math too. I love these concession stand math problems. So, $3.50. What's something that would cost $3.50?
Nacho ring.
Okay, nachos, maybe a drink, okay? Let's say you're getting nachos or a drink for $3.50 at a concession stand. Parents hand you $7.
2.
How many can you get? 2. 2 of the item. Any leftover money? Nope. Does that concession stand math help anybody here? Is that helping anybody? Okay, good. Might be something we're a little more familiar with, okay? If it doesn't help you, well, just think of normal math then. That's fine. 10 to the negative 6 divided by 10 to the negative 4th. What do we end up with from that? You subtract them. Negative 6 minus negative 4.
But there's 2 negatives.
2 negative. So we add those. Negative 6 plus 4. 10 to the negative second. Ends up being our answer. Question on that? Alrighty. So on this worksheet, guys, on numbers 19 through 22, okay, we notice those problems look a little bit different, don't they?
Yeah.
Okay, those should be division, okay? Those should be like the last three we did on our notes, okay? So like number 19, for example, should look like this. 6.6 times 10 to the third divided by 1.2 times 10 to the negative third. And really all of 19 through 22 should look like this with a division in between those two, okay? It just didn't copy correctly, okay? Any question on that? I want to make sure everyone understands that, okay?